Alright, moving on. Number 3 on the study guide. I have a sled. My sled is pulled by 2 children. Children pull with 2 forces. I have a force this way and a force that way. Alright, so 2 forces. A is 6 newtons. I'll call this force A, and that's 6 newtons. 25 degrees up from the positive x direction. So if that's the positive x direction, that angle is 25 degrees. Right, and I have to, it's kind of a bird's eye view, so I'm going to define that way as x and that way as y. So I have a force B, another child, is also 6 newtons, 25 degrees below the horizontal. So this is also 25 degrees. So they are mirroring each other. Draw a free body diagram illustrating the x and y components of the vector A and B. Solve for those component forces. And then calculate the resultant force by summing the x and y components of A and B. So we need to break these into components. So if I have just force A, I'll do that in blue, and then I'll do force B in red, and I'll make that red just like that. So, alright, so this is 6 newtons, and I want to find its horizontal component that way, and a vertical component that way. So I want to find FAX and FAY. With what I do have to do that with is that angle right here, 25 degrees. So I need to use some trigonometry to do that. Now the cosine of that angle would be adjacent over hypotenuse. Now if you think of FAY as being over here, if you just moved it, it would make a triangle, and that would be the opposite side. But I want the cosine, so I want the adjacent side. So that's FAX over the hypotenuse, which is FA. Now if I want to solve for FAX is equal to FA times the cosine of theta, assuming 25 is our theta, is our angle theta. So let's solve for that. FAX equals FA, which is 6 newtons, times the cosine of 25 degrees. And depending on your calculator, put it in carefully, whether you type cosine, then the number, or the number, then cosine. Also make sure your calculator is in degrees when we're doing this, if we're using degrees. So 25, the cosine of that is on a different calculator, because that one doesn't have it. 25 cosine of that is 0. I'll round this a little bit. You don't need to round, you can leave it in your calculator if it's 0.96-ish, just so you can check my work as I go, times 6. So I should have a x component of 5.44 for FAX, right? So now if I want the y component, that's equal to 5, oh wait, no, x, sorry, 5.44. If I'm about to do the x component, since I did cosine for the x component, I would use sine for the y component, because sine of theta, or theta 25 degrees measuring down here, would be the opposite over the hypotenuse. So the opposite in our case is FAY, and our hypotenuse is FA, the original force. So again, solving for FAY and rearranging this equation is FA times the sine of theta. So FA is 6 newtons. The sine of theta would be the sine of 25, which in our case is about 0.423. Again, you can keep it in your calculator so you don't have to round. It should be, excuse me, should be 2.5, about 2.5 newtons. 2.54, I should be. We're using 3 digits over here, I'll keep 3 digits over here. I'm not too concerned with significant figures right now. 2.54 newtons for FAY. FAX was 5.44. So there are my two x and y components for one of these forces. And the nice part, that's mirrored on the other side. It's still a 25-degree angle, so this whole thing flips over. The x component is still 5.44. The y component is 2.54, just in the other direction. So if I was going to redraw this sled with those components, I'd have, if the red components, I have a force here of FBY, which is 2.5 newtons. I'd have a force outwards, which is FBX of 5.44 newtons. And then from A would be pulling upward, FAX equal to 2.5 newtons. And then FAY is equal to 5.44 newtons. So that's all the forces acting on it. So if we want to add up the forces and look at the forces in the x and y direction, some of it, they're working against each other. All the vertical forces here, the y forces, they're working against each other. So those are going to cancel out. So the sum of the forces in the y direction equals positive 2.5 newtons plus a negative 2.5 newtons, because it's in the opposite direction. So those forces add up to 0. Now if I do some of the forces in the x, that's not going to be 0. So that is, I have 5.44 from the blue one, and I have 5.44 from the red one, which gives me 10.88 newtons in the x direction, and 0 newtons in the y. X, total FX, total FY.